A very good morning to you, dear children. Very happy to meet you all in this physics online class. Before I begin today's class, have you ever wondered the physics beyond walking, jumping, running, and simply sitting? What is the physics behind this? Yeah, we are into today's class of Newton's third law of motion. That explains why do we sit balanced, how do we walk, how do we jump, and how that all that is possible. It is all because of Newton's third law of motion. Yes, before I start, I would like to give a quick recap of what I have done in the last classes. You remember we did with first with motion in the first unit. What causes motion? Force causes motion. So the effect of force is motion. There we come Newton's first law of motion and Newton's second law of motion, and now we are in Newton's third law of motion. In Newton's first law of motion, a body continues to be in the state of rest unless otherwise an external unbalanced force act on it. Okay, the body continues to be and wishes to be in the state of rest or in the state of motion. That is called inertia. Okay, so it is also called as law of inertia. Yes, and now Newton's second law, you remember? So a balanced force cannot make any moment. Once there is unbalanced force, there is moment. Newton's second law, while understanding Newton's second law, we understood the concept momentum. What is momentum? Somebody there? Momentum is the product of mass and velocity. It is the product. Okay, a object which has mass and a velocity, it has the momentum. And we understood what is second law of motion. The unbalanced force, the rate of change of momentum is directly proportional to the unbalanced force act on it. You remember those examples? Why do we experience a forward pull when the bus starts, and when there is a brake applied on in the bus or a car? Why do we move forward? It's all because of inertia. Inertia of mass, inertia of rest, and inertia of motion. And what are the other things we have done? So when there is, you remember the catch, or you remember the glass tumbler, when we put on the ground, it will not break. It will break, but when you put on the bed or a pillow, it will not break because the rate of change of momentum is reduced. Ultimately the force is reduced because the time is increased. You remember Newton's second law? F is directly, can you see that? Capital F is directly proportional to mass into acceleration. This acceleration is v minus u divided by t. So it's inversely proportional to t. That means when the time is increased, the force is decreased. When you increase the time by moving your hand, by the way, you are you're decreasing the rate of change of momentum. Rate of change of momentum. Momentum means mass into velocity. So you are not making the velocity to come down immediately, but you are taking time to make the velocity to come down. So you're reducing the rate of change of momentum. So this rate of change of momentum, this is m into v. If that is reduced, ultimately this is directly proportional, so force is reduced, so that you will not hurt in your hand when you catch the ball. and at the same time we are increasing the time. You are not catching the ball like this, but you're catching the ball like this. You're increasing the time. That will reduce the force. Yeah. Okay. That is Newton's second law of motion. F is equal to m into F is equal to m into a, or m into a, mass into acceleration. Now I have given some problems and some questions related to that, and I have taken such a lot of time and pain to make that video of more than 40 to 45 minutes, but some of you have done very well. I appreciate Shirley. She has got the first place, and Valerian, Siddharth, and Catherine got the second place. I appreciate you guys, and Arokya, Sandana, Vikrant, and Subhashri. They have got the third place in the Google Forms. I appreciate all of you who have done well. At the same time, you see, I have asked very easy questions. What is momentum? It's a product of mass and velocity. What is force? Is directly proportional to rate of change of momentum. That's all. You could have got 2 marks. It's a theory question, but some of you got 0 mark, 1 mark. I am really disappointed. Some of you are simply doing, or I don't know what you're doing. But remember, guys, these marks in the Google Forms are taken into account, and that will be given as your internal marks for the test. Okay, the Google Forms you are doing from the month of July, August, it will be taken as a first internal marks or first cycle test marks, and from the month of September that will be taken for second cycle test marks. Okay, do it carefully and do it seriously also. Now we are coming into the very interesting part of our lesson, and very interesting part in physics. What is that very interesting part? You might be wondering that. How do we walk? What is the physics behind it? How do we swim? How do we jump? All are because of the physics that is involved in it. That physics is Newton's third law of motion. Now, in Newton's third law, in Newton's first law and second law, we remember that force changes the motion. Okay, but in the third law of motion, so when one body exerts a force on the other body, there will be an equal and opposite force from the second body to the first body. Okay, this is called Newton's third law of motion. Okay, let me give some examples. So before I give an example, again I say, when a force is applied from one body to another body, an equal and opposite force will be applied from the second body to the first body. Okay, in simple terms, Newton's third law says every action has equal and opposite reaction. This is in simple terms Newton's third law. Usually people may not remember first law and second law, but third law they used to remember. Every action has equal and opposite reaction. Now, these forces, A is acting on B and B is acting on A. They are equal. The magnitude is equal, but the acceleration is different. Why the acceleration is different? Now I will say from the examples. So in Newton's third law, it is a pair of force. It is not a single force. In all other cases, it is a single force, unbalanced force. You remember, unbalanced force. That single unbalanced force causes the body to move, to make motion, single force. But in Newton's third law, it always applies to two different forces. Remember, two different forces. One force is action force on the object, and the second force is reaction force, object from the object. So to the object and from the object. This is Newton's third law of motion. There is a very easy example that was given in the book: spring balance. Uh, you have a spring balance that is tied on the wall, or on a wall mount. Okay, there are two spring balances: spring balance A, spring balance B. When you pull the spring balance B, both will have same measurement. Why? Because when you pull B, it is exerting a force on A, and the A exerting a same force on the opposite side of B. So you will have the same reading in both the spring balances. This enumerates that Newton's third law is equal and opposite. Okay, that is with regard to the things that is in the laboratory. How can we see in our day-to-day life? If it doesn't apply to our day-to-day life, physics has no meaning at all. So what is our day-to-day life? Now I'm sitting in the chair. How do I sit? Because I'm sitting, I'm not going down. My gravity is not pulling me down. Why? It's because the force that is exerted on the chair, and the chair is exerting a force on me, so that I sit comfortably. Now, how do we walk? How do we run? How do we swim? It's all because of Newton's third law. You see, how do we walk? We are walking, this is ground. So we are walking, our legs are on the ground. When I exert a force on the ground, the same amount, equal and opposite force that is exerted from the ground to my leg, so that I move forward. So I press backward, I press my leg backward, so the ground is pushing me forward and I am moving. For example, if there is no ground and there is no force applied from the ground, can I move? I cannot move. I cannot go anywhere. Okay. So when I keep it on the ground, and when I pull it, when I push it back, the same force is pulling me forward. I am taking the second step. The second step, again I am pulling it backward. Again I am moving forward. And a wonderful example is swimming. And if you are gone for a boating, how do we go? How do we swim? You see, you're putting your hands and you're pulling the water backwards, right? You're pulling the water backwards, so the water is pulling you forward. The medium and the water is pulling you forward, and you're moving. Okay, so it is because of that you're moving, or else you cannot move. And another very good example is, now you might have gone to Ooty or Kodaikanal or any other place for boating. Okay, there is a boat, and this is the shore, or this is the bank, this is the boat. Okay, when I jump from the boat to the ground, to the bank, okay, this is a bank, this is water, and this is boat. Okay, so when I jump from the boat, I am pulling the boat backward. So when you are jumping from the boat to the land, immediately the boat moves backward, because the force that is exerted by your leg is pulling it backward, so that the boat is moving you forward. The force exerted by the boat is moving you forward. The moment the wonder, or what to say, the very way of walking or running It's all because of this understanding of the Newton's third law of motion. And one very good example is gun and bullet. Gun and bullet, or you can watch some videos like Cannonball, Birangi, okay, the cannonball, and when it's pushing the bullet, or you might have seen from Sriharikota all the rockets that is launched from Sriharikota and from NASA, how it moves, how it escapes the velocity and moving into the space. Because you see, when the rocket is fired, it exerts a pressure. The engines exert a greater amount of force and pressure on the ground so that the rocket is moving upward. And the another example is the cannonball, or simply the gun and the bullet. Okay, when I recoil the gun, you see, when I trigger the gun, you see, for example, if you see the big guns like AK-47 and other guns, it weighs too much. When they trigger the guns, the the bullet goes on the other side, and at the same time the gun recoils backward. Why does it happen? The gun is moving on this side, and at the same time the the bullet is going on this side at very high velocity, but you see, this the gun is recoiling back like this, jerk. Why does it happen? It's because it exerts the same equal and opposite force on the other side. Gun is moving on this side, so it exerts a force on the other side so that the gun is moving back. Or else you might have seen that cannonball in in the in the Birangi. Have you seen the Birangi? Okay, when they fire the cannonball will move up, but the whole vehicle, the whole machine will come backward. This is because equal and opposite forces acting. Now, when I say that equal and opposite, why does not why the gun is not moving at the same speed as that of the bullet? You might ask this question, no? You should have this question, right? The gun is moving at very high speed. If the force is equal and opposite, then the gun also move at the same speed, no? But it's not moving at the same speed. It's a small speed, no? Less velocity. Why? You might be knowing that if you have understood Newton's second law of motion. Second law comes acceleration, mass and acceleration. Because the mass of the bullet is high, it moves very, when the mass of the bullet is less, so it takes a very high velocity, but the mass of the gun is very high, so it does not experience that velocity. Yes, slight velocity. The mass of the bullet is less, so it takes high velocity, but the mass of the gun is more, so it takes less velocity. Mass and velocity, you remember Newton's second law, that's momentum. The same, I said, no, jumping from the boat to the land. So when I jump from the boat moves backward. But if I jump from the ship, will the ship move backward? Same force, no? Why the ship is not moving? Because the mass of the ship is very huge compared to the mass of the small boat. So this is what is Newton's third law of motion. Every action has equal and opposite reaction. Hope you have understood all those things. Newton's first law, second law and third law. In the next class, I will explain law of conservation. conservation of momentum and some problems connected to it. Some of you have submitted your self-introduction. Thanks to you guys. And many of you have not submitted. That's not so good. Speaking of you, the second assignment will be from the first unit. Okay, I will give you the second assignment that you have to copy all those things in the classwork notes and you take a photocopy and send me. That I will take it as an assignment. We will complete chapter 1 and chapter 2 for the next coming test. Okay, hope you're doing well, doing good. Complete the first assignment so that I know about you and ultimately do the second assignment also. Thank you. Have a nice day.